Hello and welcome everyone to my YouTube channel. And today we're going to focus on subnetting some IP addresses. And beforehand, one would need a basic understanding of binary numbers and their equivalences, uh, the CEDAR classes interdomain routing, um, CEDAR notations, and one would also need to understand a little bit about what a subnet mask is in order to start creating these subnets. Um, and as we go through today in this video, there's a couple of basic rules that I like to follow and shortcuts that I take in order to create these subnets. So I'm going to start by choosing just a basic sub or a basic IP address, and then going to give it a CEDAR notation. So let's see. I'm going to choose 214.201.60. And then we're going to give it a CEDAR 16. So first thing we do is, well, I have it here in order. First thing we're going to do is find a subnet mask and break it down to its binary, the IP address. And then from those, once we get this information, we're going to look back here to this paragraph and find out the network address, the broadcast address, first usable host or first usable address, and the last usable address. And then we're going to find out the number of hosts, doing a little bit of math there. So let's see. First thing we need to do is find the /16 CEDAR notation, and we write that out by writing 16 ones in, let's see, so we're going to write that 2, 3, 4, 5, 6, 7, 8, and that's the first octet. 5, 6, 7, 8, and that equals our 16 for the second octet. And then an IPv4 address has 32 bits inside of it. So of this 32 bits, we have 16 already present. So the remainder is just going to be in zeros. So let's see, we got 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And that would give us our /16. And now we're going to go ahead and do our IP address. And that's what I have this little chart here on the side for. So we're going to do a little bit of math. Let's go ahead and the calculator. You all can see it here. So I'll just, okay, so here we have 128. So what we're doing here in each octet, 214, 14, 201, 60, is what we're trying to make the number for each octet. And we'll get our binary representation by marking off which of these numbers we're selecting to create the number. And any combination of these will create this numbers you see here. So, well, the right combination. So what we do is we'll look and we'll say, is 128 less than 214? And we'll say, yes, it is. So we'll count it. And I'll just mark it off by putting an X there. And then we'll say, is 128 plus 64, 132, 192, is that less than 214? And if it is, then we'll count it. And I just like to mark where I am with the number so that I know where I am with my addition. And then we'll say here, and I know just by doing this a little bit, is 192 plus 32 less than 214, and it is not. 192 plus 2 is 194, plus 10 is 104, plus 10 is 214. So we're gonna put a slash there and the X's will represent ones and the slashes will represent zeros. And we'll see once we start adding them here, the importance of the ones and the slashes. And we'll say, does 192 plus 16, does that equal greater than 214? And it doesn't. 192 plus 6 is 198, plus 10 is 208. So we'll count that one. And we'll just put the number 208 here. And does 208 plus 8, is that greater or is that less than 214? No, it's not. So we're going to put a dash there. And does 208 plus 4, is that greater or less than 214? It is less than 214, so we're going to count that. And that's going to give us our 212. And we only need the 2. And that's going to give us our 214. We could just make a slash here for the 1. So the combination of these x's and 1's again represent 1's for x and 0's for the dash. So I'm going to write that out. 1x for 128, 1x for 64, a 0 for 32, an x for 16, well actually a 1 for 16, a 0 for the 8, a 1 for the 4, 1 for the 2, and a 0 for the 1. This is the binary representation of the number 214. And there's a little shortcut that I'll explain at the end. We'll just do a couple of these subnets, and there's a little shortcut that I'll explain of why this subnet mask portion of the binary is important. Like where it ends and where it begins. You could do like a quicker version of this math by just focusing on the subnet mask. And again, I'll show that in the end. So we'll go ahead and we will just delete here to go ahead and do our second octet's binary representation. And that was a 14, so that one's going to be pretty quick. So 14, what we need here is 6's, well, 128 is obviously too much, so we're going to make that a dash. 64 is too much, so we'll make that a dash. 32 is too much, so that's a dash. 16 is too much, 8. Okay, so 8 we would count because that's less than 14, and that would give us our number for our 14 that we would need. So we're going to mark that off by an X as for our 1, and then we need another X, and that'll make our binary or our representation of 12. And we just need another. We need another X here for another 1, and that'll give us our 14. We'll make a dash here for that last number because we don't need it. So the binary representation of 14 is going to be 0, 0, 0, 0, 1, 1, 1, 0. And 201. We'll work on that one next. So I'll do that. Okay. So the binary representation of 201, we're going to include the 128, and that'll give us our 128. We're going to include 64 because 128 plus 64 is definitely less than 201. In fact, that is 132 plus 6, that's 192. Let's see, that's 192. And let's see. So we only need 9 more. So that's going to be these binary. Well, there's going to be these digits down here. So we're going to put a minus or a dash there. We don't need a 32. We don't need a 16. We do need 8. We don't need a 4. We don't need a 2. And we do need this one here to give us 201. So the binary representation of 201 is 1, 1, 0, 0, 1, 0, 0, 1. And the last one we have here is 60. Okay, I'm going to write 60 next for the binary representation. And by the way, each octet in a binary, each octet is the equivalent of 255. So all these digits here equal up to 255. So let's go ahead and do our 60. 128 is greater, so we can't use that one. 64 is greater, so we can't use that one. we'll use 32. And 32 plus 16, 32 plus 6 is 8, plus 10 is 58. Or excuse me, 32 plus 16 is 38, plus 10 is 48. So, and we'll put that here. And let's see, 48 plus 8 will give us 56. And we just need 4 more. We'll count the 4. That'll give us our 60. And then we'll put dashes for the numbers we don't need. So the binary representation of 60 is 00111100. Okay. And that sped up version or shortcut I was mentioning is a good opportunity to mention that here. So this /16 is important because it lets us know what part of this subnet mask in the IP address is the the subnet mask. Which portion of that is the network and which portion is the host? The network is going to be the bits that are counted. So this first 8 plus this first 8, which equals 16, that'll be our network portion. And the last bits or the remaining bits would be for our hosts, our host. So that would be 16 itself. 16 plus 16 is 32. And again, an IPv4 address uh, has 32 bits inside of it. 8 plus 8 is 16, plus 8 is 24, plus 8 is 32. So, uh, so essentially, what we're going to do is we're going to follow the rules up top here now because we don't actually need this chart anymore. I'll clean it up. And we're going to go to the paragraph above and we're going to follow these rules here. So NA is represented, is the network address represented by the NA. BA is the broadcast address. FU is first usable. LU is last usable. And then there's a little equation there to find the number of available hosts for the network. So there's a rule here for our network address. And that is we're going to use all zeros, where the subnet mask ends to find the network address. So what that means is we're going to count, let's see, we're going to count everything here and we're going to use all ones. And I forgot to write well, actually it's here. Bits before the subnet mask ends will remain the same. And what that means is any portion of the IPv4 address that is included in the subnet mask by all ones before it ends, that portion of the IPv4 address will remain the same. So because the subnet mask ends here at 16, we're going to include 214 and 14 as a part of the network address. And 14. Clean this up here. Okay. So now what we're trying to find is the network address. And how we find the network address is we use all zeros where the subnet mask ends. So this is going to be represented by a 0. And this last octet is going to be represented by another 0. Why? Because with the network address, that's the rule. Where the subnet mask ends, before it, the IP address will remain the same, and where the subnet mask ends will replace the binary with all zeros pretty much, and that's where we have the 0 here for the third octet and the 0 here for the fourth octet. So we're going to work on the broadcast address, and the broadcast address is similar, except for we're using all ones where the subnet mask ends. And again, bits before the subnet mask ends remain the same. So we're going to put 214, clean that up. Got 14. And then again, the broadcast address is going to be represented by all ones. And what that means is if we were to add this chart here all together, that would give us 255 each bit, which would be represented by a 1. The 128 will be represented by a 1. The 64 will be a 1. 32 will be a 1, so on and so forth. This combination equals 255. So that would be the broadcast address if we made these all ones, 255. And we're going to make the last one 255 also. Okay. So the first usable host is going to be the first address after the network address. So we're going to copy 214. I'm going to copy 14. And we're going to drop 255, or I'm sorry, and we're going to drop the 0. We're still focusing on the network address, the first usable address. And then the first usable address, since this is the binary representation of 255, the first usable address here in an octet. So I'm going to write out 250. Well, I'll write out what 255 looks like here. So this will be the 128. This will be the 64. This will be the 32. This will be the 16. This would be the 8. This will be the 4. This will be the 2. This will be the 1. So essentially, what the subnet mask looks like here in all ones, that's 255. So the first usable address would be actually just the 1 here. So we're going to write or type the number 1. Okay. And the last usable host is actually going to be the broadcast address. And it's going to be 214.14.255.254, because what that looks like is this in binary. It's going to look like this. It's going to be the octet with all the numbers chosen within the octet, except for the last octet or the usable host here. So that's going to be 214. 14. That 255. At 254. Then for our final part of this IPv4 address, what we want to do is find the amount of usable hosts, and the equation I have here for everyone is up top here. So 2 to the power of the number of remaining bits left over from the subnet mask minus 2 is the number of hosts available for the network. And that formula again is 2 to the power of number of remaining bits minus 2. So the number of remaining bits in the subnet mask of 16 is 16. So we're going to get the calculator out for this one because this is pretty big math. Okay, so what we're going to do is plug the number here into the parentheses. And we're going to do the math, and that is 2 to the power of 16 equals minus 2. It's going to give us a total of 65,534 usable hosts. 534. Okay, and there we have our where right here, what we just did is we found our network address, our broadcast address, our first usable host and last usable host for this IP address with subnet mask 16. We have 65,534 usable hosts available. Now, what we're going to do is we're going to double check that. Let's see. We're going to double check this. I think you all can see it from here. We're going to double check that by visiting the address URL subnetting.net. It's a pretty neat site. I don't even think you need to make an account or anything like that. Just got to go to free subnetting tools, IP calculator, and then we're going to get our IP address here. Copy. Or you can just Control C everything. Control C, Control V. Pretty sure everyone's familiar with those. And Control V. And then we had a / I think that was 16. And the results. Let's see if I can make this smaller. Yep, okay. So the network ID or the network address is supposed to be 214.14.0.0. So we got that one right. We're going to do the broadcast address or the broadcast IP, and that one is going to be 214.14.255.255, and our first usable host here is going to be 214.14.0.1, and our last usable host is going to be 214.14.255.254. And our number of hosts here is 65,534. So very good. We got that one done, everyone. One more mention. On the exam, what I like to do as a shortcut is find where the subnet mask ends. And with these rules, I know that I'm supposed to use all zeros where the subnet mask ends. And for the broadcast address, I'm supposed to use all ones where the subnet mask ends. And basically what that means is, and the bits before the subnet mask ends remains the same. So in this case, just repeating it, the interesting portion starts, I would say, I'll represent that by a slash, / here, or / here. And so the interesting portion starts here. So what that means is for the IP address, if we're looking at the rules, as you can see, everything before the subnet mask remains the same. In the exam, if they give you the / 16, which are pretty easy CEDAR notations to find out, they give you the / 16, you know immediately, okay, we got our first 2 octets, and that's represented by 16 in the subnet mask. So that means the first 2 octets in my IP address is going to remain the same. And everything behind the subnet mask, the first 16 bits, that's where the changing is going to happen. So for the network address, everything behind the subnet mask became a 0, and everything behind the broadcast address or the broadcast ID, that became 255. Again, because we used all ones here, and then this little chart, if you add all these together, that equals 255. So very good. We have ourselves IP address that was subnetted. Make sure if you have any questions, just leave them in the comments, and we will be able to have an exchange there. Have a great rest of your day, and thank you for watching the video.